The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
You'll recall, or at least some of you will recall, that last time we ended up looking at a simulation of a drunken university student wandering randomly in a field. I'm going to return to that. Before I get to the interesting part, I do want to call your attention to something that some people seemed a little bit confused by last time. So you'll remember that we had this thing called performed trial. And the way we basically tested the drunk, what would happen is we would call this passing at a time, the number of steps, the amount of time that the drunk was wandering, and the field. And there was this one line that I blazed past probably too quickly. So what that line is saying is from the field, we're going to call the method getDrunk, which is going to return us a drunk. And then we're going to call the move method for that drunk, passing the field as an argument. Now the question is, what would have happened if I had left off these parentheses? There. A volunteer? We'll do the experiment in a minute. And by the way, I want to emphasize the importance of experimentation. I was kind of surprised, for example, to get email from people saying, well, what was the correct answer to question 3 in the quiz? And my sort of response was, why don't you type it and find out? Right? When in doubt, run the experiment. So what's going to happen, what would have happened had I failed to type that pair of parentheses? Anybody? Well, what is getDrunk? It is a method. And remember, in Python, methods, like classes, are themselves objects. So getDrunk would have returned an object which was a method. And then, well, let's try it. And the error message will tell us everything we need to know. Function has no attribute move. Sure enough, the method does not have an attribute move. The instance of the class has the attribute. And so what those parentheses did was tell me to invoke the method getDrunk. So now, instead of that being the method itself, it's the result returned by the method, which is an instance of class drunk, and that instance has an attribute move, which is itself a method. This is a very common programming paradigm, and it's important to sort of lock into your heads the distinction between the method and an invocation of the method. Because you can write either, and sometimes you won't get an error message. You'll just get the wrong answer. And that's kind of bad. Does that make sense to everybody? Does it not make sense to anybody, maybe is the question I should ask. All right, we'll go on and we'll see more examples of this kind of thing. Now, last week I ran this several times to see what would happen, and we saw that, in fact, contrary to most everyone's expectation, the longer we ran the simulation, the further the drunk was from the starting point. And we saw that by plotting how far the drunk was after each time unit. We ran it several times. We got different answers. And at that point, we should ask ourselves, is that really the way to go about answering the original question, which was, how far should we expect the drunk to be? The answer is no. I don't want to sit there at the keyboard typing in 400 examples and then in my head trying to figure out what's, quote, typical, unquote. Instead, I need to organize my simulation so that it runs a number of trials for me and summarizes the results. All the simulations we're going to look at, in fact, almost all the simulations anyone will ever write, sort of have the same kind of structure. We start with an inner loop that simulates one trial. And that's what we have here, right? We happen to have a function. So when I say an inner loop, what I mean is not that I'll write a program with a bunch of nested loops, but that I'll write a program with some function calls. And down at sort of the bottom of this stack will be perform trial, which simulates one trial of some number of seconds in this case. And then I'll, quote, enclose, unquote, the inner loop in another loop that conducts an appropriate number of trials. Now, a little bit later in the term, we'll get to the question of how do we know what an appropriate number is. For today, we'll just say a lot. And we'll talk about that a little bit more. And then finally, what we want to do is calculate and present some relevant statistics about the trials. And we'll talk about what's relevant, and I want to emphasize today the presentation of them. Last time we looked at a graph, which I think you'll all agree was a lot prettier to look at than an array of, say, 1,000 numbers. All right. So now on your handout and on this screen, you'll see the way we've done this. So perform trial, we've already seen, so we know what the inner loop looks like. We can ignore first test. That was just my taking the code that I had inline last time and putting it in a function. And now what you'll see in the handout is perform sim and answer question. So let's look at those. So perform sim, sim for simulation, takes the amount of time, the number of steps for each trial, plus the number of trials. It starts with an empty list, dist short for distances here, saying so far we haven't run any trials, so we don't know what any of the distances are. And then for trial in range number of trials, it creates a drunk. And I'm putting the trial as part of the drunk's name, just so we can make sure that the drunks are all different. Then I'm going to create a field with that drunk in it at location 0, 0. And then I'm going to call perform trial with the time in that field to get the distances. What does perform trial return? We looked at it earlier. What is perform trial returning? Somebody? Surely someone can figure this one out. I have a whole new bag of candy here, post-Halloween. What kind of thing is it returning? Is it returning a number? If you think it's returning a number, oh, good. You're going to tell me what kind of thing it's returning? Please. A list. Thank you. And it's a list of what? I'm giving you the candy on spec, assuming you'll give me the right answer. List of distances, exactly. So how far away it is after each time step. This is exactly the list that we graphed last time. So perform sim will get that list and append it to the lists. So dist lists will be a list of lists. Each element will be a list of distances, right? Okay. So that's good. And that's now step 2. In some sense, all of this is irrelevant to the actual question we started with in some sense. This is just the structure. Then I'm going to write a function called answer question, or ansQuest, designed to actually address the original question. So its 2 is going to create a list. This is a list called means. Then it's going to call perform sim to get this list of lists. Then it will go through that and calculate the means and create a list of means. And then it will plot it. And as we'll get to before this lecture is over, how the plotting works. So I'm following exactly that structure here. It calls this function, which runs this an appropriate number of trials by calling that function, and then we'll calculate and present